Hello, I'm Paloma. In my main part on the project was creating and developing the concept we were going to work with. We decided to propose a better application using a decentralized system for issuing skill certificates. It's the most common use of validating knowledge we may find online and very much used for applying for job openings to we are sure we have that knowledge, but the problem someone may encounter when receiving the certificate from a participant is to verify if it's not forged or if it is totally valid. So these are not easy to contest and they vary in their format. So what is a beginner's level to some is not to others, and we don't have the standard. So what we want here with this application is to create a application that we can totally verify if a certificate belongs to someone and if it is totally valid. So with the decentralized certificates, we could start the certificates on chain, guaranteeing that all the data in the previous blocks are publicly available and immutable, and the community then would assure whatever level means. So this is a Python beginners level, and the community assure it is beginners level or an intermediate level, so we could have a type of standard, and we could also have it possible to change. So for what is desirable for everyone. The system also doesn't require you to trust the person who is sending you the certificate, neither the company that certified them. If the certificate follows the protocol, then it's inherently trustworthy. And since we provide the contract, other issuers who want to use it will also be trusted. So we have the trustless and expandable properties and values.
About the storage of our application, we store data both on-chain and off-chain. Due to the high cost of storing data on-chain, a separate system is used to integrate the certificate into the blockchain due to their high amount of data. However, it is still undesirable to lose the advantages of a centralized storage. For this reason, the certificate data, name, owner, issuance data, and type, is stored on the Interplanetary File System, IPFS, where anyone can access the data as easily as they can access the on-chain data, but for lower costs. And on-chain, we store only a pointer to the information on the IPFS. So this pointer contains a path to the certificate data. We also store on-chain the token holder info. Through a contract, a user will be able to get the IPFS base URI and quickly retrieve the off-chain data. Now about the use cases of our application. The first use case is an user wanting to get certified by our application. To that, the user goes through Know Your Customer, represented by adding the name in our application. And then the person takes a test to validate their skills on the selected language and skill level. To complete the test, the user must pay a certification fee so that they can mint their certificate. The second use case is validating a certificate issued by the application. There are two ways to find the certification to make sure it is a valid certificate. First, it is possible to get the IPFS path directly through the smart contract in Blockchain Explorer, for example, like Etherscan. The second option is to go to an official or community website of the application and search for the certificate ID. Now this slide is showing a sequence diagram for the sequence of events that follows the user clicking the mint button so that they can receive their certificate. The website sends the user data to the backend so that the backend can create and sign the JSON containing the user information. This JSON is then sent to the IPFS and returns the metadata URI, the path to the file of the certificate. The backend then builds a transaction called min certificate that receives the metadata URI for the user to sign and pay the correct costs. Upon signing, the certificate will be available as soon as the transaction gets approved.
Okay, so now I'll do a quick breakdown of the functions of a smart contract. One thing to note is that since the actual certificate data and the signature are not handled in the blockchain, the basic idea of the blockchain is just to connect a wallet to a specific certificate in the IPFS. The functions of a smart contract are actually quite simple, with the base one being the min certificate function, which receives the URI for a certificate in the IPFS storage. And this is called by the backend once a user actually passes a test to say that such user has the access to the certificate. As I said, the token URI is the IPFS path of the JSON file for the certificate. And since the blockchain doesn't actually handle the validation of the certificate itself, it's important that this IPFS file should be signed by the controlling entity and should be pinned in IPFS so that it can be easily accessed. So anyone can actually call the min certificate function, but if the certificate lacks the signature, it will simply be void. Other than the min certificate function, we only have some secondary auxiliary functions which are used for maintenance and other such things, which are the pause function, which stops issuance of the certificates until it's unpaused. This can be used in case a security flaw is found or something like that. Then we have the unpause function, which allows the issuance once the pause function has been called. And then we have the set price, which is used to adjust the certificate mining price in the future. And then we have withdrawal, which allows the controlling entity to withdraw funds so that they can be further invested into development or something like that. Now we're going to do a quick demo using the simple front end we have, which contains a quick Python test. And Pedro is going to take it from here and he's going to show us his Python skills and obtain his certificate.
Yes, so as Daniel explained, this is our front end to interact with the contract. It has a quick implementation of a test. So what does int stand for in Python? Well, I think it's integral. Well, no, it does not let me proceed through the testing. But when I put in integer, then yeah, I get it. I get through it. I can go through our KYC, which is at the moment is only your name, so I can put in like Pedro Souza. Oh yeah, I also have to grab some funds from the faucet since this is a local blockchain. I will get $200 so I can mint a certificate. Now, the local transaction has been sent, the funds have been withdrawn, so now I can come here to my contract to check if I have a token to my address. So I put in my address in the balance of function, and I can see I do have one token. Now, I could verify this token either coming to the token URI function, and I get the IPFS path, or we also made a very simple front end where knowing the ID, you can just come here, put in your token ID, and get your IPFS link from this. It takes a little bit of time to open IPFS since we don't have a proper gateway set up on this browser, but as soon as it loads, we can see the data stored there. As we can see, we have here the certificate that has just been stored with the name that was in this case inputted, but it ideally is taken from a good KYC method. The wallet that matches the wallet of the user. The timestamp, so let's say that a company wants you to have taken the test in the last 3 years or something, you can check timestamp. Then you can have the type and the level of the certificate.